Hare Krishna to everyone. So, before going inside our microcontroller concepts or programming, we'll briefly discuss how the program, whatever we have written as a user application, how it is going inside our microcontroller. So, here it will, you can see, this is our user application. Suppose you have written that LED blinking or any timer configuration, any timer application you have did, or any RTOS or any QP application you have written that program. So first step, it will happen the compilation. Okay, from compilation, what you will do, you will compile the all the .c files into object files. Okay, relocatable files, all the relocatable files, and that relocatable files, it will link all the relocatable files and it will convert into one hex file. Okay, it will link all relocatable files, it will give you one hex file. That from one hex file, what we'll do, that one hex file, it will go inside your microcontroller by using our openOCD command. Okay, I'll tell you, in this course actually we will not use any IDE. We'll write our code in notepad, and we'll write a linker script, we'll write startup code, we'll write make files, how we can compile all our .c files. So we'll do everything from scratch, we'll not use any IDE. While debugging also we'll do in by using openOCD command lines. Okay, so this is the program flow. Okay, so first you have your user application going to the compilation, all the .c file, it will link into, it will merge and it will give one elf file, .elf file, or and .elf file, or will convert into hex file, and that hex file will dump into the our microcontroller by using openOCD commands. And for the compilation and linking, we will use our uh, ARM GCC compiler command lines. Okay, so with that command lines we will compile, and with linker files we'll link all these files. Okay, so this is our course process, and this is the process of compiling one project, and it is going into the flash. Okay, uh, right now we discussed program flow, so in detail we'll discuss about the build process. Okay, so first we'll this is our source file. From source file, it will go to the pre-processing stage. First is pre-processing stage, uh, and after that our code generation stage is there. After that, assembler, and then linking. These are four stages we have. Okay, first in pre-processor stage, it will generate your .c into .i. Okay, from parser, what will happen, it will check your syntax or semantics, everything it will check from checker, from parser, and from parser it will go to the .s. Okay, it will from the parser, from the code generation will generate .s file, that is your assembly file. Okay, from assembly file will pass to the assembler, it will generate your object file. That is object file is relocatable. So we'll understand while developing our startup code, or every means linker file, and we'll understand why it is called as relocatable. We'll understand in that section. Okay, so after that object file will pass all, means object files, it is not one actually, it will give multiple object files, like we have means we have different .c files, no? So all the object files will link all the object files inside the linker, and that linker, it will generate one elf file. Okay, and from object copy tool we can generate our hex file. This is our build process. So this is our build process. So if you're not understanding also, will while writing our startup code and everything from scratch, we'll go in detail and we'll understand how it is generating. We'll go through the command line section. In that section you can understand how it is converting. how the pre-processing stage, code generation stage, assembly stage, and linking stage is happening. So firstly, how the microcontroller, inside the microcontroller, how the program is going. So directly it won't go into the main, actually it won't jump into the main. So first what will happen, our program counter, so it will load the address, and where we have to run the program. That address is it in program counter. Okay, so what are the address is in program counter, that address or that line is running actually inside the controller. So the program counter. Okay, so first what will happen, the program counter will load zeroth address. From zeroth address it will go to the stack address. From stack address it will go to the reset handler. Okay, from reset handler, what we'll do, inside the reset handler we have to initialize the data section. There are different sections are there. So we'll place all the like what are the different code blocks are there, no, like uninitialized data section, or initialize, or static data. We have inside the code, we have the inside program, we have different data actually, in static we have, and like that we'll place that all the data into different section. Okay, so first what will happen, reset handler, after reset handler it will initialize the data section. After initializing data section, we'll initialize the bss section, and bss section it will initialize all standard c libraries. Okay, and then it will go to the main, and it will start to execute your program. Like this, the sequence of reset handler. Okay, so first it will load the zeroth address. After that it will go to the stack address, top of the stack address, whatever it is, like will go to the reset handler. Okay, from there, from reset handler we will initialize all the data section, bss section, c standards libraries, and then it will go to the main. So for example, I have I will give you some brief what you can say, brief overview what we can write inside the program. Okay, so this is our uh, different you can say handlers functions. So see here, you can see first is our stack, top of the stack address. After it will go to the reset handler, and then reset handler it will go to the whatever the handlers, NMI handlers are there, hard for handlers, mem management handlers, bus fault, user fault, SVC handlers. We'll explore what are the handlers, exception handlers, and what are the our means all different handlers we'll explore. And these are our peripheral exceptions, or DMA, or CAN, or timer, I2C, UART. These are timer exceptions. So these are loaded with different address. Okay, so in when it will go to the reset handler, we'll initialize the data section, we initialize the BSS section, and then we initialize the standard library, and we'll initialize by developing the code, and then it will go to the main. Okay, so like that we have startup file. We'll write this startup file. Okay, so